Welcome to the podcast. This is Mr. White.
Mr. Johnson.
And today we're going to talk about curved mirrors. And this is, of course, different than the conversation we had last time about flat mirrors.
Is it more than just that it's curved?
That would be more than that. What we should have noticed in our investigations for flat mirrors is that the images were always virtual, meaning they were inside the mirror.
Could you say it was like a mirror image?
Ah. And that's a nice thing to say because the image is always upright from top to bottom. So, when you're looking in the mirror, your head is still on top and your feet are still on the bottom of the mirror, which sounds strange until we start to talk about some curved mirrors. You're always the same size. You're not bigger or smaller or distorted or anything like that. The only major difference is that things on the left and things on the right are inverted.
Now, inverted sometimes means upside down, but here you're just talking, when I raise my right arm, it looks like the mirror is raising its left.
Or the lettering on your T-shirt is
reversed.
Strange.
Okay.
Right? So that's what we're talking about. This is an always scenario.
You mean I can't turn a mirror off?
No. And as long as you are emitting some kind of light, and that light is going into the mirror, a flat mirror, virtual, upright, same size, left to right is inverted. Curved mirrors are different. We have two kinds. We have convex, and we have concave. Okay? We're going to talk about both today and what kind of images they form and try and talk about some different items here. The first one I want to talk about is the one that we are most or more familiar with. That would be the convex mirror. And I say that because somewhere on your car, there's probably some wording that says objects in mirror may be closer than they appear. Maybe. Do you think that's an appropriate, is that correct? Maybe? Or should we use maybe a different term altogether? Like, objects in mirror are always closer than they appear.
Well,
I mean, unless you're right on top of it.
Well, the physics speaking, yes, we could always use the word always.
Okay.
Lawyer speaking, yeah, got a COA, if you know what I mean.
Okay, so
you got to say maybe.
Maybe. So I like to draw arrows because arrows are easy to draw.
Plus they have a point.
And they have a point. And so this is what a convex mirror does. We're going to practice drawing some of these things. A convex mirror has something behind the mirror in this virtual space back here called a focal point. Okay, labeled with a lowercase f. My arrow, or my object, is in real space. And so some things happen. The light, just like our flat mirror, from our object is going to travel towards the mirror. Now, we have rules. The first rule is go parallel, hit mirror, then through F. My real lines are always solid. My virtual lines are always dashed or dotted. My image has to appear, the tip of that arrow is going to appear underneath this dashed line somewhere, whether it's up here or down here. The second rule is I take aim at F, hit mirror, okay, then parallel. Okay, so I'm going to aim for the focal point. I'm not going to get there because the mirror is in the way, and I'm going to go through like this. So I have an intersection right here, which means that is where my mirror is going. That's where I'm going to find the image in my mirror. Now these lines, by the way, they also go back into real space, but my reflected lines here with the arrows, they never intersect. So an image can't form there.
So then, this is the picture that we're seeing with a mirror on our vehicle. The reason why it says maybe appear closer, if it looks smaller, it looks further away.
That is correct.
Oh, okay.
So these images are always virtual, upright, and smaller. And as long as we follow our rules for image formation, we can make these predictions. We can also trust our eyes, but we've talked about that in class. Be careful what your eyes are telling you. The information may be good, but your brain is tricking you.
Mm-hmm.
That's a convex mirror. These show up in your cars. Gas stations have them so that they can check out what's going on down the aisle, so the gas station attendant can stand by the cash register and make sure no one's stealing stuff off the shelves. Curved mirrors are items that can do that.
For around corners, too.
For around corners as well. All right, and you guys got to play with those in class a little bit as well. The other type of mirror is a concave mirror.
Now, when I was a kid, the best way for me to remember concave and convex, because they kind of seem similar, is that concave is the one that kind of looks like the opening of a cave. So it actually bends around.
That's a really good idea. I had never thought of that. Concave is a curved mirror. It does open up, just like a cave, but we're going to follow our rules. Now, the difference between a concave and a convex mirror. Convex, the focal point was behind the mirror in virtual space. Concave, the focal point is here in real space. Okay?
Now, can the focal point move?
No.
Okay.
The focal point is determined on how curved the mirror is. The more curved the mirror is, or the less curved, then we adjust this F, and it slides somewhere on this line. By the way, we call this the PA. We call it the principal axis. I'm going to follow the same rules. I'm going to go parallel. I'm going to go through F. Okay, remember, virtual is dashed, real is here. Then I'm going to go through F, and then I'm going to go parallel. What do you notice about my virtual lines? Will they ever intersect? They're not going to meet.
No.
What do you notice about my reflected lines in the real space, though?
That they're meeting actually in front of the object.
Yeah, and this has to be where the tip of my arrow is, which means that I have a real image. Okay, I have an inverted image, and the size will vary based on object location. You might use one of these mirrors, like if you're a woman, this is like a makeup mirror. It can be used to magnify, so you can actually make the image bigger than the object is. You can make the image smaller. You can make the image the same size. But this is why we don't use them in your car. So I got my concave mirror again. And here's my focal point, and that's fine. I'm going to put the object right at the focal point. Now, you don't use these when you drive your car, but I can guarantee you that magicians use these to pull off magic tricks.
Whoa, whoa, whoa. Magic's real.
Sure it is, yes. So you go parallel, and you go through F. Okay. Oh yeah, and this happens too. All right. And then I need to go through F, hit the mirror, and go parallel. Is that correct?
Yeah.
Yeah. Am I ever going to hit the mirror?
No.
Will that light ever reflect?
No.
It can't.
No.
And so as a result of it not being able to reflect, okay, reflected rays never intersect. Will an image form?
No. So is that how it disappears?
That's how it disappears.
Wow.
So they line the object up, they put it right at the focal point of the giant mirror, and then you just watch it just disappear into thin air. This, by the way, is why you don't have one of these for your rear view mirror in your car. I swear, officer, nothing was there.
But I saw your lights at 1 minute and you were gone.
Right. So the concave mirror is definitely a different animal, okay? You can vary the size, it can be upside down, it could be right side up, it could be a whole bunch of things, but it can also not be there at all. And so that's a little tricky when we start talking about this. So convex mirrors have everyday applications. Concave mirrors, okay, we can start thinking about magic. All right, we'll write this up here, driving. I can spell. Here we go. All right, and as opposed to the flat mirrors, which we also have some everyday experience with. So is there anything else? Did we Did we get it all?
I think we did get it all.
Let's check that out.
So then what you're saying is that in the movies, the Twilight movies, those vampires really don't have a reflection because they're using concave mirrors?
Probably.
So it's not really a special effect.
I've never seen.
Well, they're vampires.
They're
So vampires are not supposed to have reflections?
Oh, so they must not be emitting any light?
Right.
You can't reflect any light. That's
That's
strange.
why they're pale.
Right. I'll have to watch those in my free time. All right, so I think that covers curved mirrors. All right, so hopefully you took some notes. Maybe you took a screenshot and printed it out so that you can review how those drawings are made. But we did some image prediction today, and I can guarantee you that's going to show up on the test since I'm the guy that writes the test.
Yeah.
Yeah.
I'd write down the 2 rules too, because
How-
it'll make making those images a lot easier.
A lot more help, yeah. So I believe that covers it. So signing off, this is Mr. White.
Mr. Johnson.